Hello, ladies and gentlemen. So today we're going to be learning about vector application. So let's get started. By the way, this is a calculator. Oh, can't spell calculator. This is a calculator section. Okay, so let's get started. So first and foremost, they want us to write out the component form of the resultant vector by resolving the horizontal and vertical components. This, by the way, is already the magnitude of v. So we already got this part. So that's extremely convenient. Okay. Now let's label this side x and this side y. Those are the things that we want, are x comma y. That's what we need. So let's compute that. First and foremost, let's go ahead and figure out this angle. That's just 90 minus 66. Use your calculators and you get 24 degrees. So that's 24 degrees. Okay, awesome. Now we use SOHCAHTOA. So so, ka, and toa to figure out, let's figure out x first. So x, this would be my adjacent, and then I have the hypotenuse already, which is 3.7. So this would be ka, so cosine of 24 equals my adjacent x over hypotenuse 3.7. So multiply both sides, x equals 3.7 times cosine of 24 degrees. All right, hip hip hooray for that. So we have our first part. So v equals, what was it? 3.7 times cosine of 24 degrees. And now we just got to figure out y. So y is my opposite over hypotenuse. So that's going to be my so. So that's going to be sine of 24 degrees equals my opposite, which is y, over my hypotenuse 3.7. Multiply both sides by 3.7. So y equals 3.7 times sine of 24 degrees. And so this is 3.7 sine of 24 degrees. And there we go. There's the do now. That's how you figure that out. Quick SOHCAHTOA stuff we've done before. So let's go ahead and move on to the next part. So for this example right here, we have an airplane and it's flying with an airspeed of 310 knots with a bearing that is north 50 degrees east. And then we have, if a 78 knot wind is blowing north 55 degrees west, determine the speed and direction of the plane relative to the ground. Okay, well, first things first, we have to draw out the situation. So we start off with a T. So this will tell us the direction. So north, south, east, west. Okay, and so first and foremost, an airplane is flying with an airspeed of 300 knots, north 50 degrees east. That is, actually, let me use a different color. I'll make that blue. So right here, starting from the center, we'll go like that. Okay, so this is 50 degrees, and this is going at 310 knots. Okay, and this is all about vectors. Remember, we're essentially going to do the exact same thing we did up here, but with this. Okay, and so now let's see. Then the wind is a 78 knot wind is blowing 55 degrees west. So I'll do the wind in red. So this is going something like that. And then this distance right here is 55 degrees. And this was going 78 knots that way. Okay, so now what we want to do is we want to label these as different vectors. So I'm going to label the blue one as u, okay, and then I'm going to label the red one as v. So now let's go ahead and calculate this really quick. So if I want the vectors for u, well, I need to know this angle, okay, and that angle is going to be 40 because it's 50 minus 90, or 90 minus 50, gives us that 40 degrees. So that's that right there. Okay, so to get the vector format of u, it's going to be the cosine sine version. Cosine is with x, so this would be 310 knots times cosine 40. And then this one is 310 knots times sine 40. Okay, and then once we use our calculators in degree modes to calculate that, our u becomes 237.474, comma, and then 199.264. That's all calculator work, okay? Then we need to figure out what V is. So V was the wind, and we need to figure out exactly, well, I'll highlight it in purple, this angle right here. And so that's just 90 plus 55, okay? And so 90 plus 55, okay, let me just get that right there. 90 plus 55 gives us, it's going to be 145, okay? So now I can make the vector component of this. So this would be 78 times cosine of 145, and then 78 times sine of 145. Remember, this has to be in degree mode when you do this on the calculator. So V equals negative 63.8939, comma 44.739. Okay, that's calculator work. So now when trying to figure out how these are affecting it, because of course if a plane is flying this way and there's a wind hitting it going that way, the plane would end up somewhere over here. So then now we just add up the vectors. This becomes a simple u plus v. And so when you add up the x components, which I'll highlight in, let's say, let's do it in green. So you're going to add up the x components, and then you're going to add up, which I'll do in pink, the y components. You end up with this, okay? So simple calculator work. You get 173.58, and then the y component is 244.7, oh, sorry, nope, 244.003. And so right there, we have the component form of where the plane would be. Now this is useful because now we can calculate the magnitude, in other words, the speed. So if I get the magnitude of this, of u plus v, which is just the square root of the x component squared plus the y component squared, this would give us 173.58 squared plus 244.003 squared, and then the whole thing square rooted. This is going to equal, and calculator work, plug and chug, 299.445, in this case, knots. This is the speed of our plane, because depending on how fast, and notice, the plane was supposed to be moving at 310, but because the wind is giving it some extra work to do, it's taking away some of its speed. Not a lot. It started with 310 and ended up with 299, but it did lose some speed because of the wind. And these are what pilots have to consider. Now, that's how you get the speed. Now, the direction is very easy to figure out. You're going to use tangent, okay, because it's all about x's and y's. So tangent alpha, or whatever symbol you want to use, you're always going to do equals y over x. And we have an x component and a y component. The x component was the pink stuff, so 244.003. And then we divide by the green stuff, which is our x component, 173.58. Okay? Calculate that really quick, and you end up with tangent alpha of 1.40572. That's just calculating. Now, we've done this before. How do we get rid, I'll do it in orange, of a tangent? You do inverse tangent. Make sure your calculator's in degrees. So now alpha is going to equal inverse tangent of 1.40572. Okay, and then when you calculate this with the calculator, alpha is going to be 54.57 degrees. Now that's the angle. That's specifically, and I'll do this as a orange angle, that's specifically this angle. So I didn't draw this as perfect as I could have. If anything, that means that this line should be somewhere right here, really, because it was only pushed a little bit. because originally it was supposed to be 40 degrees and then it was only moved 50 some degrees. Okay, so I need to have this in bearing format. So to get a bearing, then this would be 90 minus whatever answer you got. And so this would equal 35.42 degrees. And so finally, here's how you write out your bearing or the direction. North, 35.42 degrees east. And so there we go. We have our problem all nice and done. So thank you so much for listening, guys. I will see you all next time.